Up there in the vast silence of space, something massive is showing its age. The International Space Station, once the crown jewel of human engineering, is quietly groaning under the pressure of time. It's like an old, creaky ship trying to stay afloat in a sea of stars. Back here on Earth, NASA isn't just watching, it's reacting urgently. With the future of human presence in low Earth orbit hanging in the balance, NASA is turning to private companies to carry the torch forward. One rocket, one name is suddenly in the spotlight: Blue Origin's New Glenn. And finally, after years of setbacks, it has launched. But is it too little, too late? Far above our heads, the International Space Station continues to orbit Earth at nearly 5 miles per second. But beneath that incredible speed lies a slowing truth: it's aging and fast. Built over 2 decades ago, the ISS has endured wear and tear, declining systems and rising maintenance costs. And despite the achievements it has enabled, it now faces the ultimate countdown. With limited international funding and technical limitations, the station's retirement is just a matter of time. NASA, which has been the leading force behind the ISS, knows this, and that's why it's pushing harder than ever to ensure something else is ready to take its place. NASA's solution doesn't lie in building another massive government-funded space station. Instead, it's leaning into the future, the commercial space sector. The agency is partnering with private companies, hoping their innovation, speed, and cost efficiency can carry forward America's legacy in space. This is where Blue Origin's New Glenn comes in, a heavy-lift rocket that's been long promised, long delayed, and finally in 2025 delivered. It's one of only a few rockets capable of hauling large-scale modules and essential cargo into orbit. And with the looming end of the ISS, that capability is no longer just impressive, it's critical. New Glenn's successful launch in January 2025 was more than just a test flight. It was a signal. NASA has pinned major hopes on this rocket, and not just for occasional cargo runs. New Glenn is meant to support a brand new kind of space station, Orbital Reef. Think of it as a next-gen outpost in low Earth orbit, privately built, commercially operated, and designed to be flexible enough for research, manufacturing, and even space tourism. It's a bold vision, and Blue Origin, funded by Jeff Bezos, is leading the charge alongside Sierra Space, Boeing, and Redwire. With NASA backing the project with $172 million, the pressure is on. Orbital Reef is designed to host up to 10 people. That's fewer than the ISS, but enough to carry out a mix of scientific, industrial, and private missions. It's being pitched not just as a lab in space but a business park in orbit. And for that to happen, reliable transport is key. Enter New Glenn, the massive rocket expected to ferry everything from structural modules to life support systems into space. Standing over 320 feet tall and equipped with a reusable first stage, it's a technical marvel. But it hasn't had an easy road. The second flight of New Glenn is already on the horizon. A new upper stage, nicknamed GS-2, has been delivered to Cape Canaveral's Launch Complex 36. There, it entered the horizontal integration facility to be mated with other parts of the rocket. Once ready, it will roll out to the pad for a round of tests, including a critical static fire of its twin B-3U engines. NASA's Aerospace Safety Advisory Panel has publicly expressed optimism that this second flight could happen as early as June. That optimism, though, also acts as a polite warning: no more delays. And delays have certainly been a defining feature of New Glenn's journey. When Blue Origin first announced the rocket in 2016, it boldly aimed for a first flight by 2020. But that timeline quickly unraveled. Developing a rocket of New Glenn's size, especially one with a reusable first stage and a massive 7-meter fairing, was never going to be easy. 7 B-4 engines were needed, each one a technological challenge in its own right. Issues with engine design, testing protocols, and integration forced repeated changes to the timeline. By early 2020, New Glenn's first flight had slipped to late 2021, then to late 2022. Meanwhile, Blue Origin's B-4 engines were being delivered to United Launch Alliance for use in the Vulcan rocket, but New Glenn remained behind schedule. In early 2023, another delay was announced, pushing the launch to 2024. This time, the cause was more complex. Blue Origin needed additional time to finalize testing on its reusable stage and landing systems, which are critical for long-term cost-effectiveness. Throughout 2024, Blue Origin faced growing comparisons to SpaceX. While Elon Musk's company was launching Falcon 9 rockets at a near-weekly pace, Blue Origin appeared sluggish. Critics accused the company of being too cautious, too slow. But internally, the company stuck to its guns, prioritizing reliability and system verification over flashy launches. It was a risky strategy in a market that rewards speed, but one the company hoped would pay off in the long run. Still, another delay arrived late in 2024. This one was linked to complications with New Glenn's modular payload system and continued refinements of the B-4 engines. But finally, on January 16, 2025, New Glenn took flight. The launch was successful. New Glenn reached orbit. However, the mission wasn't perfect. The attempt to recover the rocket's first stage failed. It was a bittersweet victory, showing both progress and lingering technical gaps. Leadership changes in 2023 signaled a shift in the company's culture. Dave Limp replaced Bob Smith as CEO, with a mission to speed things up and modernize internal operations. Under Limp's direction, there was a renewed push for accountability, streamlined development cycles, and greater transparency. These changes, though gradual, appear to be making a difference, especially with New Glenn now moving steadily toward a second launch. So what caused all these delays in the first place? It boils down to complexity. New Glenn is not just a rocket. It's a heavy-lift reusable system designed to support multiple missions. The first stage, with its 7 B-4 engines, had to undergo rounds of testing. Even though B-4 engines worked well in the Vulcan rocket, adapting them to New Glenn's size and reusable design posed new challenges. Payload integration, especially with a larger-than-normal fairing, created additional design and software issues. Blue Origin also chose to avoid shortcuts. Rather than gamble with under-tested systems, the company postponed launches in favor of additional ground tests. This decision may have cost time, but it likely prevented more expensive failures. At the same time, watching SpaceX dominate headlines with frequent launches didn't help Blue Origin's image. Internally, the comparisons triggered new conversations about how fast the company should be moving. And while not often discussed, Blue Origin's work on other major projects, including the New Shepard suborbital craft and the Blue Moon lunar lander, may have diverted attention and resources away from New Glenn in earlier years. The company simply had too much on its plate. Imagine living on a crumbling spaceship, knowing every creak might signal the start of something far worse. That's the silent reality aboard the International Space Station right now. Orbiting hundreds of kilometers above us, this marvel of engineering is entering its twilight years, and the pressure to find its successor has never been higher. While NASA has pinned hopes on the private sector, one name, Blue Origin's New Glenn, is under a sharper spotlight than ever before. But there's a growing fear behind the scenes, that this new generation of space infrastructure may not arrive soon enough. And as the clock ticks, the risks grow, not just for systems but for human lives. NASA's increasing push for New Glenn's rapid development isn't simply about innovation or even progress, it's about survival. At a recent public meeting, the Aerospace Safety Advisory Panel, or ASAP, didn't mince words. They described the ISS as being in the riskiest phase of its entire existence. The station has survived decades in low Earth orbit, but it now faces mounting threats, many of them caused not by space itself, but by tightening purse strings on Earth. According to ASAP, the most immediate and dangerous challenge to the ISS is a deepening funding shortfall. Maintenance is getting harder. Critical safety measures are being stretched thinner. And vital decisions about repairs are now being made based on budgets, not urgency. The harsh truth is that time is catching up with the ISS faster than new technologies are catching up with time. Many of the station's core systems were designed and built during the late 1990s and early 2000s. Though remarkable upgrades and repairs have extended its operational life well beyond original expectations, the infrastructure is wearing thin. SAP reports that certain parts of the station have not only aged, they've surpassed their intended design life. That makes every repair more complex, every fix more expensive, and every misstep more dangerous. Small malfunctions that once were routine can now spiral into larger risks as the system becomes increasingly fragile. Worse still, even when engineers know what needs fixing, limited financial resources often prevent timely action. SAP highlights how funding restrictions don't just impact what NASA can spend, they limit how that money can be allocated and when. This creates bottlenecks in maintenance schedules and reduces NASA's flexibility to react to problems on board the station. Repairs that might have been straightforward a few years ago now compete for priority. Delays are no longer inconvenient, they're dangerous. And as time drags on, these delays begin to cast a shadow over what matters most: the safety of the astronauts living and working aboard the ISS. While NASA remains committed to maintaining stable operations, it's becoming clear that the margin for error is shrinking. That margin is what has kept astronauts safe through emergencies, malfunctions, and even meteor strikes. With the ISS aging and budget constraints tightening, the ability to preserve that safety buffer is weakening. NASA's concern, and that of its advisory bodies, is no longer just about maintaining functionality. It's about protecting human lives. And that's why the agency is urgently supporting the rise of commercial replacements. New Glenn is one of them, but it's not the immediate fix that the ISS needs right now. Despite NASA's hopes, New Glenn's first missions are not directly focused on ISS replacement efforts. Instead, its early flights are tied to Amazon's Project Kuiper, a satellite constellation meant to rival SpaceX's Starlink. While the rocket may one day carry modules for the Orbital Reef space station, its current use case doesn't alleviate the growing pressure on the ISS. Orbital Reef itself is still in early development and won't be operational before 2030, the same year the ISS is scheduled for decommissioning. So even if New Glenn performs flawlessly, it won't directly address today's most pressing concerns on board the ISS. Still, if New Glenn can prove itself reliable by 2025, it could change the future. A consistent launch cadence would allow Blue Origin to accelerate Orbital Reef's deployment and help shift NASA's financial burden toward commercial partners. That wouldn't be an overnight solution, but it could shorten the gap between the ISS's end and the beginning of the next era in space habitation. At the very least, New Glenn's success would provide critical infrastructure for future missions, enabling everything from science research to industrial manufacturing and tourism in low Earth orbit. But again, this is a long-term strategy, one that may arrive too late to solve the crisis at hand. NASA isn't putting all its eggs in one orbital basket. Alongside Orbital Reef, the agency is evaluating other commercial options. One of the most advanced is Axiom Space Station, developed by the Houston-based Axiom Space. Axiom plans to build a modular, commercial space station that will serve research, private missions, and space tourism. The first module will actually dock with the ISS before the full station operates independently. This bridge approach could ease the transition. Designed by famed French designer Philippe Starck, Axiom's interior blends futuristic style with functionality, featuring large observation windows, video walls, and the largest cupola ever designed for a space platform. Another ambitious player in the race is VAST, a private aerospace company based in Long Beach, California. Their project, Haven 1, is a more compact yet fully functional commercial station, targeting a no earlier than May 2026 launch aboard SpaceX's Falcon 9. Designed to host 4 astronauts on 30-day missions, Haven 1 will rely on SpaceX's Crew Dragon capsule for life support and transportation. The station measures 10.1 meters in length with a diameter of 4.44 meters, offering 80 cubic meters of pressurized volume, 45 of which are habitable. Its structural material of choice, aluminum, was selected over stainless steel for better performance and faster manufacturing. VAST has already revealed a full-scale mock-up of Haven 1, and it's turning heads. The design is surprisingly cozy, featuring padded white walls, warm maplewood accents, and personalized sleep pods tailored for zero gravity. A new video walkthrough offers a peek inside this small but refined spacecraft, showing how commercial space living is evolving far beyond utilitarian design. Even under strict budget and schedule constraints, VAST's commitment to comfort and efficiency stands out. The company initially explored stainless steel construction but shifted to aluminum in March 2024 after performance testing and supply chain realities forced the change. As all these efforts unfold, a clear picture emerges, a future with multiple commercial stations supporting different missions. But that future is still under construction, while the ISS is slowly running out of time. Whether it's Orbital Reef, Axiom Station, or Haven 1, the challenge isn't about building the next station. It's about building it fast enough. And as NASA watches the clock tick down on the ISS, every delay, every setback, and every cautious move from the private sector makes the urgency even more pressing. The transition from the ISS to its successors is no longer just a matter of policy or preference. It's a race against decay.